Okay, in our previous video we talked about the Pythagorean theorem, and this time we're going to talk about the converse of the Pythagorean theorem. So we're going to start out by stating the Pythagorean theorem in if-then format. So if a triangle is a right triangle with legs A and B and hypotenuse C, then a squared plus b squared equals c squared. And in fact, I could state this, I could state the Pythagorean theorem kind of in picture form. If I have a triangle that's a right triangle with legs A and B and a hypotenuse C, then a squared plus b squared equals c squared. That's the Pythagorean theorem. Well, I could also state the converse of the Pythagorean theorem in this kind of picture format. If a squared plus b squared equals c squared, then I have a right triangle with legs A and B and hypotenuse C. Remember, to form the converse of a conditional statement, I want to swap the hypothesis and the conclusion. So that's all I've done. So the actual written down statement of the converse of the Pythagorean theorem would actually read slightly differently than if we just swapped, just kind of took this part and swapped it with the part after the if. We'd say, if a triangle has sides of length A, B, and C, and if a squared plus b squared equals c squared, then the triangle is a right triangle. Now that's kind of a long way of stating it, and for most people, just thinking of this kind of shorthand pictorial format is enough to remind them of the Pythagorean theorem and its converse. The important thing here is just that not only can we state that if we have a right triangle, then we have this relationship between the three sides, but if we have some triangle and we can show that we have this relationship between the three sides, then we know that we have a right triangle. That's all the converse says. Well, we can use what we know about the converse of the Pythagorean theorem to determine whether we have a right triangle or not, given the lengths of some of the sides. So in your notes it says, given three potential side lengths of a triangle, first, do they form a triangle at all? And second, if they do, is it a right triangle or not? Now remember, in order to determine if three given side lengths can actually form the lengths of the sides of a triangle, we have to determine if the sum of each pair of sides is greater than the length of the third side. So let's check this one out. 3 plus 4 is going to be greater than 5, so that checks. 3 plus 5 is greater than 4, so that checks out. And let's see, 4 plus 5 is greater than 3. So yes, it's a triangle. It's a triangle. Now we want to know, is it a right triangle or not? Well, in order to do that, we just need to find, first we're going to have to determine which one of these is going to be our longest side, because that matters. Obviously number 5 is our longest side, so this is going to be side C right here. So let's see what 3 squared plus 4 squared, I'm going to see if that's going to be equal to 5 squared or not. So 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25, 25 equals 25, so yes, this one is a right triangle. Let's try example number 2. Again, first I want to know, do the three sides form the sides of a triangle? So let's see. 3 plus 4, that's 7, that's greater than 6. 3 plus 6, that's 9, that's greater than 4. And let's see, 4, 6 is 10, that's greater than 3. So yes, it's a triangle. And now let's see, does it form a right triangle? Well, again, our longest side, that's going to be this side right here, so this must be side C. So 3 squared plus 4 squared and 6 squared, we want to know what's that relationship. Well, again, we have 9 plus 16. This is 36. 9 and 16 is 25. 25 is less than 36, so this one is not a right triangle because of the Pythagorean theorem. We know that if it were a right triangle, then 3 squared plus 4 squared would be equal to the third side squared. So this is not a right triangle. Example number 3. All right, let's check to see, is it a triangle? So we have 5 plus 10. Let's see, 5 plus 10 is 15. 15 is not greater than 16. Therefore, this one is not a triangle. So we don't need to go any further. Once we know it's not a triangle, it's not going to be a right triangle. So we can say it's not a triangle. We'll go on to example number 4. Example number 4, is this a triangle? Let's see, 3 plus 3, that's 6, that's greater than, that's greater than 4. 3 plus 4, that's 7, that's greater than 3. And the last one is also 3 plus 4, which is greater than 3. So yes, this is a triangle. Now we want to know, is this a right triangle or not? So let's see. This is going to be my side C right here. Let's see if a squared plus a squared plus b squared is going to be equal to c squared. So this is 9 plus 9. 4 squared is 16. So let's see, 9 and 9 is 18. 18 is greater than 16. So this is not a right triangle, because if it were, then I would have a squared plus b squared would be equal to c squared. This is my a and this is my b. Okay, well, that's easy enough, but what I would like to do is something a little bit more. I would like to actually use the Pythagorean Theorem Converse to determine, once I know that a triangle is not a right triangle, like I know right here and right here. Well, remember, there are actually 2 other ways that I can classify triangles according to their angles. A triangle can be a right triangle, it can be an obtuse triangle, or it can be an acute triangle. So I would like to be able to determine if these 2 triangles, not only are they, I know they're not right triangles, but I would like to know, are these acute triangles or are they obtuse triangles? So let's take a look at how we can determine that. So here I've got a right triangle. I've got it labeled A, B, and C. And I know from the Pythagorean theorem that a squared plus b squared equals c squared, because that's what the Pythagorean theorem tells me. Well, here I've got 2 other triangles that I've started to draw. I haven't finished drawing them yet. And I've made the lengths, the first 2 lengths of the sides of my triangle, the same lengths as A and B on my right triangle. Notice that on the second triangle, I've taken my right angle and I've kind of widened it a little bit. I've made this into an obtuse angle. And so what I'd like to find out is, if I make this angle here a little bit wider, I make this into an obtuse angle, what's going to happen if I try to make a triangle here? Well, if this is my, let's say this length right here is my, let's call this my original length C. Well, notice as soon as I make this angle larger, as soon as I make this an obtuse angle, this third side, my side C, it no longer reaches to the other side, to this corner up here. It doesn't make a triangle anymore. In other words, if I want to make a triangle, if I want to make an obtuse triangle using these same 2 lengths here, A and B, I'm going to have to make my side C longer. So my new C is going to have to be longer than it was before. In other words, a squared plus b squared, which are still the same length, I know this is an obtuse triangle. But now my C is larger, and since my C is larger, but A and B are both the same length, then a squared plus b squared must be less than c squared. In other words, they started out a squared plus b squared was equal to c squared, but as soon as I make that angle an obtuse angle, in order for it to still be a triangle, I've got to make my third side, c, longer, and that's going to make the c squared part bigger than a squared plus b squared. That's the relationship between a squared and b squared and c squared when I have an obtuse triangle. Let's do the same thing where we take this triangle and now instead of making that angle there bigger, I'm going to make it smaller. In other words, I'm going to make this into an acute angle, which means I'm now going to have an acute triangle. Well, what then is going to be the relationship between a squared plus b squared and c squared? Well, once again, if I make this angle smaller, notice that my side C, which started out that long, again, this is kind of my, if I want to think of this as my original side C right here. Well, now my new side C is going to be shorter. In other words, if I make this angle smaller, I make this into an acute angle, my side C is going to have to be smaller than it was when I had my right triangle. So if C is smaller, well then c squared is going to be smaller than a squared plus b squared, which means I'm going to have this relationship. A squared plus b squared is going to be greater than c squared. Well, that tells me that if a squared plus b squared is greater than c squared, I must have an acute triangle. Now, these relationships I can use on the previous examples to show that if I have a relationship between a, b, and c for a triangle, and it's not equal, a squared plus b squared is not equal to c squared, now I can say more than just, well, it's not a right triangle. I can say whether it is obtuse or acute. So let's take a look at those. So example number 1, 3, 4, and 5, I remember that formed a triangle, and in this case, I had 3 squared plus 4 squared. That was 9 plus 16. And that was 9 plus 16 is 25, and 25 equals 25. This was my right triangle. For this one, however, remember we had 3 squared plus 4 squared and 6 squared. 3 squared plus 4 squared, 6 squared. So this was 9 plus 16 and 36. This was 25 and 36. Well, in this case, I had a squared plus b squared is less than 36. Well, before all I could say was that this was not a right triangle. Now, with what I've just learned, I can say that since I've got a squared plus b squared is less than c squared, I can say that this is an obtuse triangle. So it's less than, so this is an obtuse triangle. Example number 3, remember this was the one that did not make a triangle at all, so since this is not a triangle, I'm done with this one. It's not going to be a right triangle, an acute triangle, or an obtuse triangle. This one, however, we had 3 squared plus 3 squared and 4 squared. This was 9 plus 9 and 16. That was 18, which is greater than 16. Well, again, before all I could say was this was not a right triangle. Now, however, since I have a squared plus b squared is greater than c squared, I know that not only is this not a right triangle, but it is an acute triangle, since a squared plus b squared is greater than c squared. So this one is an acute triangle.